students, welcome to the study of today, Introduction to Mobile Computing. I'm your host, Mike Onyoro from the School of Computing and Informatics, the Department of Enterprise Computing. I'll be taking you through the topic 1 of mobile computing, that is Introduction to Mobile Computing, and the learning objectives will be 1, to understand the basic concepts of mobile computing, such as definition of terms, definition of the mobile computing services. I'll also be taking you through exploring advantages and challenges of mobile computing while in use. And also another objective number 3, is to learn the application areas where mobile computing technology is used. And 4, to discuss cellular telephony technology with the aim of understanding the various infrastructures we have and the process involved in making and setting up a call. We'll start with definition of terms. What is mobility? Mobility is the ability to have access to similar communication services at different places. What we mean by this, I can be able to access my email at workplace, I can be able to access it at home, and I can also be able to access the same during transmission or during transit, and that's what we call mobility. Computing is any activity that uses a computer to manage, process, and communicate information. And portability is a characteristic attributed to the computer program if it can be used to run in any operating system other than the one which it was developed for initially. That leads us now to define the term mobile computing. And mobile computing is the technology that allows transmission of data, voice, and video via computer or any other wireless enabled device without having to be connected to a physical link. And the main concepts that facilitate this are 1, mobile communication, mobile hardware, and mobile software. We'll go through the definition of each so that we can be able to understand the 3 key components of mobile computing. Starting with mobile communication, this is the infrastructure put in place to ensure that there is seamless and reliable communication that is going on. And in mobile communication, it is good to understand that the media is unguided or unbounded. What we mean by that, the entire overlaying infrastructure is basically radio wave oriented, so as to allow transmission of information via the air. Mobile hardware. Mobile hardware, these are the mobile devices or the device components that receive or access the service of mobility. An example, we have portable laptops, smartphone, tablet PCs, personal digital assistants, and others. The main characteristic of mobile devices is they operate in a full duplex mode. What we mean by that, you don't have to await one person who is calling to complete what they are saying before you can revert. That one means sending and receiving of information happens at the same time in a seamless manner. Mobile software. Mobile software, this is the programs that runs the mobile hardware. We can simply say this is the mind of the mobile hardware. It deals with the characteristics and the requirements of mobile application, e.g. ensuring portability. That one means once the software has been developed or the program is developed, it can run in any platform, and the device can be able to be used in a seamless manner even during transit. Examples of mobile softwares, we have BlackBerry, which informs the BlackBerry phones. We have the iOS, which informs the Apple phones and also other devices. We have Windows Mobile, which informs the Windows operating system for both phones and laptops. We have Symbian OS, and we have Android operating system, which is one of the major operating systems for most of the phones in the market. There are key features in mobile computing. For any device to be termed as a mobile computing device, or for any communication to be termed and classified as mobile computing, it has to qualify to the 4 minimum requirements. And one of them is portability. This is the ability to move a device within a learning environment or to different environments with ease. That one simply means once I'm connected at workplace, I can be able to move to different locations without having to request for a reconnection to the network that I'm using. Point number 2 is what we call social interactivity. This is the ability to share data and collaboration between users. In the age whereby we are having a lot of interaction, a lot of companies coming together, doing mergers and working together, we must ensure all mobile computing devices are able to share data and collaboration between users. The other key feature or characteristic of mobile computing device is context sensitivity. This is the ability to gather and respond to real or simulated data unique to the current location, environment, or time. What we mean by this is the moment I move from one locality, for example, I move from the country I am to another country, whereby the context in terms of the default language that is used, the time, the geolocation, the positioning, then it means a mobile device is able to sense the context and be sensitive to it and respond by changing the settings accordingly. Point number 4 is connectivity. This is the ability to be digitally connected for the purpose of communication of data in any environment. So that means every mobile computing device must have the connectivity ability, be it to a wide area network, be it to a large area network, be it to a Wi-Fi connection. It is able to be connected and have the connectivity ability to the different environment. What are the advantages of mobile computing? Why go the mobile computing way? One of the advantages is increasing productivity. This is the reduction of time and cost for customers and business. Using the same example of portability, it is very easy for an employee to be able to work from the workplace, continue with the work in transmission, and also work from home. And that will means there is much more increased productivity other than when you are required to be in office throughout the time. Second is entertainment. This is whereby for personal use, for entertainment, and also presentation. And currently, even in the season that we are right now, like COVID-19, you find most of the entertaining, the artists have gone the mobile way of being able to produce and also disseminate their content in the internet. And it's also easily accessible to the consumers. Portability. This one means you are not bound to one zone. You are not bound to work in only one fixed place because in mobile computing, what is encouraged is the ability to have mobility, to be able to move and not to be connected to one geographical location. The other aspect is the ability to support cloud computing. This is saving documents on online servers, and whenever you make a connection to the internet, you can be able to access the same information on a click of a button. This one ensures there is portability because most devices might have limited storage, and being able to work with the cloud computing make sure that information is available on the move. Every technology comes with limitations, and some of the limitations of mobile computing include but not limited to the following. One of them is battery consumption hindrance. With high processing power with the smartphones, rarely do you find a battery going for past 8 hours normally, and that is one of the major limitations, and it's an area of research currently so as to develop batteries that can have a longer life and may be charged within the shortest time possible. The other limitation is interference is persisted in shielding. Every time there is usage of air as a medium of communication, there is the interference of radiation and other elements that interfere and cause what we call attenuation or loss of a signal strength. The other limitation is inefficient bandwidth in transmission, connection losses over the entire network, which now and then there are always reported cases of losses of connection once a base station is attacked or maybe once one of the communication channels have been interfered with by natural causes or human-caused interferences. Network stability is also another concern in terms of mobile computing, because every time there is the portability aspect and the user is moving from one point to another, that one is prone to disruption because at times the network is attenuating, and another time in some of the regions you find, given the remote nature of the area, the network may not be as strong as from the initial point of making a connection. Interoperability problem is the other limitation, and what we mean by that, you find not most of the operating system, not most of the gadgets are able to have what we have portability. You might find you have a certain device using a certain operating system and you're not able to share information with another user who is using a different operating system, creating some locking down of some users within some environment. The last but not the least is the protection constraint, whereby having a moving IP, which is the current standard of mobile communication in the fourth generation type of mobile devices, it becomes very hard, and it's an area of research to make sure the moving IP is protected, that is the internet protocol, so that at any time your mobile device is secure. What are some of the applications of mobile computing? Mobile computing goes in almost all fields of life, starting with the medical field, whereby we have mHealth applications which have eased research in terms of treatment. You can be able to assess a doctor from the comfort of the home. With even the current situation we are having globally, you can be able to assess a prescription, make an order, and have a delivery. And far and beyond that, even collaboration between doctors making very much easy to have more discovery, vaccines, and such. In the business world, we have different M-business platforms. A case of Kenyan, we have the M-Pesa, which has eased a lot of business. What we mean by M-business, we simply mean mobile business. What we mean by M-Health, we simply mean mobile health. In education, students as well as teachers have benefited a lot using the virtual learning, and most of the users who are receiving this type of communication, you are either watching it online, you are either streaming, thus you are utilizing the aspect of mobile computing by accessing virtual learning. The other aspect is what we call the airline, whereby you don't have to move to the airline to go and do your airline reservation. You can be able, on a click of a button, do reservation. And also even the management of the flights, the management systems that are in place makes it very easier to operate the movement of the aircraft. In the defense field, we have ultra mobile devices. You know, in the field whereby the army is on attack. What they will need is very small devices, devices that are not bulky in terms of communication, so that they can be able to do communication, do collaboration, and receive instruction from the command base. In terms of banking, we have M-banking. Most of the banks, they have mobile banking, whereby a customer can be able to access their transaction, know their statement, request statement, apply for loan, and such. And that's what we call mobile banking or M-banking. In construction, mobile computing has been used extensively in terms of remote communication, whereby people within a remote construction area can be able to receive instruction from their supervisors, and even supervisors can be able to use existing systems to do collaboration planning, architectural drawings, and be able to supervise and conduct instruction in various areas. For us to understand mobile computing in a much more better concept, it is good to understand the evolution of computing. It dates back, or the two axes we have in terms of the axis, we have more flexible resource usage, and also we have freedom of co-location. It starts back with the invention of single-user operating system, with the first generation computing systems. Then it came back to the batch type of processing. It moved on to time sharing, networking, large area networks, and wireless networks. And currently we have the mobile computing. What are some of the classes of mobile devices? We have what we call the display only. These are InfoPad model limited to portable processing. It has constraint. The display-only devices have constraint to operation within prepared infrastructure, like a cordless phone, and advantages with respect to power consumption because they consume less power. Upgrade path, they have also lightweight, and also they come with the impact of lost, broken, or stolen devices. The other class is what we call the laptop computer, which an example is a ThinkPad model. This is significant portable processing, which operates independently of wireless infrastructure. And also it comes with its own disadvantage because it has a higher power consumption. They are a bit more expensive than the display only. They also have a significant loss exposure and typically greater than 5 pounds, meaning they are much more weightier. And the personal digital assistance, PDA, provides somewhere in between a hybrid of the two extremes, other than having the display only or the laptop computer. Every mobile computing device comes with these three portability concern, which we have been able to see in the classification of mobile computing devices. One of them is low power. That is limited computing performance because of the processing power, which is a hybrid trying to balance out between the battery power and also the processor power. And also low quality displays as compared to the other personal computers, workstation, and mainframes. Loss of data. If a device is not in a fixed position and it's portable and it's in the move, it also brings the aspect of easy loss of the device, which comes along with the loss of information. And when we talk about loss of data, we are saying must be conceived as being network integrated, so that at any time, if the device is lost, the information is able to be maintained. The devices, mobile computing devices, also come with the aspect of small user interface. They have limited real estate for keyboards because you are dealing with a small keypad. Also the icon intensive handwriting and speech. All these are limited in terms of small user interface. as compared to having a big screen workstation which has a bigger keyboard and you're able to operate easily. The other portability concern is the small local storage, whereby flash memory rather than disk drive. And you realize most of the devices, because of the ability to achieve miniature or small handheld devices, it also comes with the problem of small local storage. That brings us now to the second section of us now understanding cellular telephony, which we're going to be discussing mobile computing generation, that is moving from first generation up to the fifth generation. We have the PSTN, Public Structure Telephone Network Infrastructure, so as to understand what are some of the components in a mobile computing environment, and also finally the process of making a call. We'll start with mobile computing generation. The same way we have first generation computers, we also have the first generation mobile phone devices. We are talking of in 1979, whereby the first generation mobile network were reliant upon analog radio system, which meant that users could only make phone calls and they couldn't send or receive text messages. That is the first generation. And also it's worth noting within the first generation, they were half duplex, whereby only at one time would a person communicate and the other person would not answer simultaneously. An example is the Motorola walkie-talkie. The second generation, which is 2G, came in 1991. This was facilitated with the invention or the coming in of the GPRS, which now was able to facilitate SMS, which was not within the first generation, the MMS, the multimedia messages, which was not also in the first generation, and very importantly, the GPRS also enabled users to send email using their mobile devices. The third generation, which is 3G, is much more younger. It came into the market in 2001, which is still in use up to date. But normally, it is when the superior 4G signal fails, then the mobile device falls back to 3G. It has some advanced features which it can be able to facilitate video call, share files, surf the internet, or watch TV online, and also play online games, which are facilities which we could not find in 2G or second generation. The fourth generation was an advancement of the 3G, which it is 5 times faster than the 3G network. And we can say in theory it provides a speed of 100 megabits per second, and it comes with the following functionality: higher voice quality than what we are having in the third generation, easy access to the instant messages services and social media like Facebook, WhatsApp, and then quality streaming and makes faster downloads. The fifth generation, which is 5G, is still currently under development, and it's a technology which should be fully blown within 2020, but in some of the developing countries, it's already in application. It is meant to deliver high multi-gigabytes per second peak and data speeds, also provide ultra-low latency, more reliability, massive network capacity, increased availability, and more uniform user experience to more users. As technology moves on, the most next anticipated is 6G. That is the sixth generation, which in practice it's actually in theory and also under development. And the whole idea of 6G is to make even 5G look much more like a second generation, so you can maybe anticipate the amount of operational power, which we also need also to consider the limitation. With the 5G, with the 6G, are we able to have high processing power and also be able to balance with the battery life of the mobile devices. How is that going to play out? And that is why we are saying it's still under investigation and in future development. Moving on to the PSTN infrastructure, the main of this is to understand the main components in a mobile computing environment. And I'll start by defining some of the terms that we use in the PSTN infrastructure, and I start with mobile station, MS. The mobile station comprises of two things. That is the mobile equipment, that we call it ME. This can be your laptop, it can be your phone, it can be your personal digital assistance, PDE, which comes with an email number attached to it. Within the mobile devices, for them to be able to connect to the networks that are available, they must use what we call subscriber identity module. In short, we call it the SIM, and sometimes we refer to it as a SIM card, which comes with various identification, international identification numbers to help to connect to the existing infrastructure. And in simple terms, those two are what we are calling the mobile subscriber station, MS. That is the combination of the mobile equipment and the chip implanted within, which gives identification to the user, which gives ease of accessing network and also being found during communication. The other component of PSTN infrastructure or a mobile computing environment is what we call a cell. A cell is simply a geographical area that is covered by a single base station in a cellular network. In drawing, it is actually represented using a hexagon, but in practice, it's an irregular space within a geographical area. And each of the cells is run efficiently using a base station, which you can see in every cell or every geographical location has a base station. So we can say a network or wireless communication comprised of a large number of base stations to efficiently use radio spectrum to cover the service area. That brings us now to define what is a base station that is being used to facilitate communication within a cell or within an irregular space of a geographical area. A base station is a relay located at the center of any of the cells of a cellular telephone system. It is a short-range transceiver. What we mean by transceiver, it has the ability to do transmission and also receive a signal, which connects a cordless phone, a computer, or other wireless device to a central hub and allows connection to a network. So that's what we call a base station, which an image is provided there. Mobile Switching Center, MSC. A mobile switching center, this is the main element within the core network area of the overall GSM network architecture in the mobile switching service center, that is MSC. What we are having here is an illustration of an MSC whereby it is able to connect to a base station, and then the base station are connected to a base station switching center, which is connected to various base stations. And that's what we are referring to as the mobile switching center, MSC, which is able to interface various base stations. PSTN, Public Switch Telephone Network. This is the world's collection of interconnected voice-oriented public telephone. This is the backbone of communication, whereby all types of communication, be it through a remote office, be it through internet, be it through a landline phone, a mobile phone, a call center, all of them are connected in PSTN, which is the backbone of the communication. That brings us now to combining all those elements together so that now we may understand the PSTN infrastructure. Right at the bottom, we have the mobile station, which we can also call subscriber mobile unit, which is a phone, which connects to a base station within a cell. And these cells, which are governed by various base stations, the base stations are able to connect to an MSC, which is a mobile switching center. And the mobile switching centers are also interconnected with other MSCs. And finally, the MSCs are also now connected to the PSTN, which is mainly, in simple terms, a backbone of communication within maybe a region or a country. Maybe at this point, I may explain this. The moment a mobile MSC, that is a mobile station, makes a call at this level, a search is done within the base station to know whether the receiver and the caller are within the same base station or within the same area. And if that is the case and the checkup is done at the MSC, which is governing the same base station, then the call is established. If that's not the case, for example, maybe caller 1 who is at this base station is calling someone in another MSC, then at that point, the search moves from the base station to the MSC. And if the MSC finds the receiver and the caller are not within the same jurisdiction of the mobile switching center, then another mobile switching center is contacted so that the same search happens. At the moment the call is established, the link is established between this base station and a base station within another MSC. What if the mobile subscriber is calling someone who is within the outside of the region of the PSTN? The same process applies. When the MSC have been able to search their registers and they identify that the receiver of the call is not within the mobile switching center, they move on to the PSTN, and the PSTN are connected also to other PSTN. And at that point, we call it roaming, whereby you are calling outside the PSTN. That moves us now to explain the process of making a call. We'll start with call establishment basics. These simply illustrate what happens. Immediately, a mobile subscriber originates a call or makes a call, a setup is done with the mobile switching center, and then after that, a setup is set with a fixed party, as explained earlier. If they are within the MSC, a call proceeding, alert is sent back to the mobile subscriber, and then an alert is sent of having established a connection, and then a connection is made from the fixed party who is receiving, and then finally the mobile subscriber is able now to connect, acknowledge, and do an acknowledgement of the connection, and that's how a connection of a call is done. The same process is done when a mobile terminated call is done, or a termination of a call. So the setup starts from the party that is terminating the call. A setup is established with the MSC, and then the mobile subscriber is alerted. The call is confirmed, and then an alerting is established to the fixed party, and the two are communicated, are connected, and then a channel can be dedicated for communication. That one brings us to the end of the first topic, which in the coming topics we'll be discussing much more of more concepts of mobile computing. So in summary, at the end of the lesson, what you should have understood is the basic definitions of mobile computing. What are the advantages? What are the disadvantages? At the same time, the ability to understand what are the hindrances or the limitations of mobile computing devices, and then a full understanding of the PSTN, whereby you can be able to explain a call setup and also a call establishment, and also be able to describe all the components within the PSTN. Thank you so much for your time.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.